Hi again. This short video will introduce you to the decision tree induction algorithm. And decision trees are another way to perform classification. And you just saw the nearest neighbor technique. And decision trees are a kind of a second way to perform classification, similar to the nearest neighbor algorithm. This material is from chapter 3 of the Provost and Fawcett book. Let's take a look at some data. So this is information that you might have within your company if you're a credit card company like American Express or Capital One. They may have, the name of the customer Mike and how much balance the customer has, 200,000. What is the age? 42. Mike is 42 years old. Mike is currently unemployed. And you have something called a target attribute or a dependent variable. And for Mike, unfortunately, his balance has to be written off. So I want to remind you that supervised learning techniques such as classification and regression operate in a context where you have some kind of target attribute or a dependent variable, something you're trying to predict, right? So in this case, the classification task is for this credit card company. You're trying to predict whether Mike will be, or a new customer like Mike will be a write-off or not. New customer like Mary, will she be a write-off or not? This is the classification that you are trying to perform. And so what we can use to perform the classification, the information available to us, is the balance of the customer, the age of the customer, and whether the customer is currently employed or not. So sometimes we call this the feature vector. So for instance, Claudio has a feature vector equal to 115,000 balance, age 40, and currently unemployed. And so what is the idea with decision tree induction? You currently have many customers on your books, and you know their balance, you know their age, and you know whether they're employed or not, possibly. And what you're trying to do is predict within the next 6 months, will this person write off their balances or not? Why is that prediction very important? Because if you can anticipate people that are going to be write-offs, you can maybe try to diminish, the amount of their charging, and you can try to control, kind of the bad stuff that happens to your company. So once again, we are operating in a classification environment. We are operating in a supervised learning environment, and we are trying to predict whether a customer is going to be written off or not based on things like features like balance, age, and employed. So how could we approach this particular task? What we could do is envision a set of rules like so. So in this picture, we have just used two of the variables available, balance and age. We have not plotted whether the person is employed or not. And so we call this a decision boundary. So what we've done is we've divided all the customers into groups. So we've said, does the customer have a balance less than 50,000 or more than 50,000? Is the customers, so for the people that have balance less than 50,000, we draw another decision boundary at age equal to 50, right, like so, and we consider whether the age of the customer is bigger than 50 or lower than 50. So in this picture, you can assume that the pluses represent good customers, meaning they're not written off, and the black dots represent bad customers or people whose balances have been written off, right? So you can see, let's go to this side of the picture. In this side of the picture, the balance of the customer is bigger than 50,000. And for customers whose balance is bigger than 50,000, we divide them into two groups with a decision boundary at age 45, and we consider whether the age of the customer is bigger than 45 or less than 45. So the age cutoff is different based on whether the balance is less than 50 or more than 50. And you can see that, so this is a mutually exclusive and collectively exhaustive segmentation of all your customers. And you can see that if the balance is less than 50 and the age is less than 50, that's pretty bad for your company, because almost all of them are written off here. If the balance is bigger than 50 and the age is bigger than 45, that seems to be pretty good, because all the customers here, none of them are written off. And so the objective of the decision tree algorithm is to develop a set of rules like so that you can perform some kind of classification or prediction. Let's take a look at the same data in a different kind of picture. So this is actually why we call this a decision tree. You can think of this as kind of a tree, kind of an upside down tree, where the root is at the top and the branches and the leaves are kind of going to the bottom. And so this is the same picture. We first consider whether the customer's balance is less than 50 or more than 50. And if the balance is less than 50, we consider whether the customer's age is less than 50 or more than or bigger than or equal to 50, to be precise. And if the balance is bigger than 50, we consider whether the customer's age is less than 45, more than 45. So what is the classification rule? If the balance is less than 50 and the age is less than 50, we are going to predict that the customer is a write-off. And the reason we predict the customer is a write-off, because if you look at this picture, 12 out of 12, all the customers here are written off. So the probability of a write-off is 1. But not every segment is so clear-cut. If the balance is less than 50 and the age is bigger than 50, you can see that 2 out of 3 customers, there are 2 pluses and 1 dot here. So 2 out of 3 customers are good. And so we predict no write-off, but we also, provide the caveat that the probability of no write-off is only 2/3. So the classification doesn't have to be kind of cut and dry, black and white. You can say the probability of a write-off is 100% here. The probability of no write-off, I'm predicting no write-off, but please be aware that the probability of no write-off is 2/3 at this leaf of the tree. We call the lowest node a leaf. And likewise, when the balance is bigger than 50 and the age is less than 45, we predict write-off, and the probability of a write-off is 4/7. And when the balance is bigger than 50 and the age is bigger than or equal to 45, we predict no write-off, and the probability is 10 out of 10. So that's this good segment right here, where if the balance is bigger than 50 and the age is bigger than 45, we have peachy customers. We love them. So this is a decision tree, and the decision tree algorithm performs a classification task. And the classification task or supervised learning task here is to predict whether the customer is going to be a write-off or not. So that's just an introduction to kind of what the decision tree algorithm does, but you should have plenty of questions in your head right now. So some of the questions are, how do we decide that balance and age are important? So if you notice in this tree, we did not use the customer's employment status in the classification, and that's possible. Sometimes you have lots of data, and if you have 100 different pieces of information, you may only want to use 17 of them to perform the classification, because the other 83 don't kind of add a lot of information to the classification task. So the questions you should be asking yourself are, how do we decide that balance and age are important? Then the second question is, how did we decide that balance is more important than age? So in the sense, we first branched on balance and only then on age. Why did we not first branch on age and then go to balance? How did we decide this particular sequence or order? That should be kind of keeping you awake. And the third question is, how did we decide the 50,000 threshold? So in other words, why didn't we say balance less than 43,000 or balance more than 43,000? How did we decide this 50,000 as the kind of cutoff value? So these are some important questions for decision tree algorithms to answer. And the way in which the decision tree decides that balance and then age is the correct order, and when you consider balance, 50,000 is the correct cutoff to use. the way the decision tree makes those kinds of decisions, pardon the pun, is based on a key idea called information gain. And so the next video will introduce you to the concept of information gain and help you understand how the decision tree conducts, branches and develops rules based upon this idea of information gain. To summarize, this video introduced you to the decision tree algorithm, and we looked at how the decision tree performs classification, and we also understood the probability of a class, meaning that the tree does not have to give you will predict a write-off or no write-off, but it will also tell you an associated probability for that particular branch of the tree. Okay, see you in the next video.